Hey Chloe, this is the second half of our tessellations section, which is like 4-5. We did the first half yesterday, and we are on example 2. Yesterday we did regular tessellations. Okay, difference between regular and semi-regular. Are you ready for this? Add this to the top right above regular. Regular tessellations have one figure repeating over and over again. Okay, one figure repeating over and over again. Now that figure is a regular figure. Do you remember what the word regular meant from yesterday? Regular. A regular figure means all sides are equal and all angles are equal, like a square, not a rectangle. Like an equilateral triangle, not this triangle. All sides are the same, all angles are the same. So a regular tessellation is one figure that's repeating over and over again, okay? A semi-regular tessellation is two regular figures that are repeating over and over again. Okay? Like the pentagon and the square that we have going on here. You see this little floor tile looking thing? Okay? No, I'm sorry, not pentagon, octagon. Octagon and square repeating over and over again. Okay? Is that an octagon? Yeah. Yeah? Okay. All right, so what we're doing here is it's going to give me two figures. It's saying an octagon and a square, and they want to know if I have all the sides that are 1 unit long, will this thing tessellate? Will all of them connect together? Okay? And the 1 unit long really doesn't make a difference at all. It's just saying that like where the octagon and where the square connect with each other, each one of those are 1 unit long. Okay? We are more so concerned with the angles. Will the angles fit together? Okay? So I look at one little intersection here. Okay? Looking at this little joint right here, and I have 3 pieces to it. Boys, are you listening? I have 3 parts. I know that this is a 90-degree angle right there with the box. But then I need to figure out how much this is and how much this is, and they all should add together to make up how much? 360. Okay, so this is 90 degrees. We have to figure out how many degrees each of the angles of the octagon are. So this guy and this guy and this guy and this guy, like what we did yesterday. Okay, so if I have an octagon that has 8 sides, and I separate him into triangles, like I make triangles out of him. Triangle, 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 triangle. How many triangles will he have? 6, because it is 2 less, right? So that is 6, and what do we do with 6? Times 180. 6 triangles times 180, because each triangle is 180. And that is 1080. And then I divide that by? 360. No. So that means 1080 is how many is inside of this whole thing? Divide by 8, which then is what? 135. Perfect. Okay, so that means this angle is 135 degrees, and then this one right here is 135. Let me make this so it's not so messy. Okay, we just found this angle is 135, and that means this angle is also 135, and this angle right here is 90. Okay, and what we're concerned with is if I butt them up against each other, will those come together in the middle and meet perfectly? Megan says yes. How do you know? You add them all up. And they have to add up to be 360, which means those are going to come together to form a perfect joint. It's going to be good. So that is those two objects will tessellate to make a semi-regular tessellation because we have 2 figures. Okay? It's not perfectly regular because there's 2 figures, but it's semi-regular. Got it? Yeah, not too bad. All right, let's go to, look at this big equation that they did for that, to figure that out. I'm not doing that. All right, let's go down to here. Classify a tessellation. Okay, there are 5 different names, not 5. There's 2 different names that it could have. It could either be uniform or not uniform. And I'm going to talk about what those look like here in a second. Uniform or not uniform. And then the second name is it could be regular, not regular, or semi-regular. Okay, let's talk about what regular and semi-regular and not regular are first. Okay, regular means one figure tessellating that has the sides are all equal and the angles are all equal. One figure that's tessellating where the sides are all equal and the angles are all equal. Okay? An example of this would be like the octagons that we just saw. Or let me do an equilateral triangle like this. Like one of these. All of these figures are exactly the same. Right? Those are all equilateral triangles. You don't have to draw that if you don't want to. But that is a regular tessellation. Okay? It's one figure that's tessellating and all the sides and all the angles are the same. Okay? A non-regular would be one figure that's tessellating, but the sides and angles are not the same. So sides or angles not equal. Like for example, let's do this one. This is a parallelogram. And he's going to tessellate like this. You see what I'm making? Why is he not regular? If I do parallelograms right together. What?
They're all the same.
What's all the same?
Shape.
All the same shape, but why is he not regular? Look at these angles. This is an obtuse angle, that's an acute angle. That's not going to work. All the angles are not the same, so he's not a regular figure, right? So he would tessellate. He's the same figure, but he's not a regular tessellation. Got it? Okay, what's semi-regular?
When
two regular figures tessellate. Two regular figures tessellate, like a square and an octagon. And we just had another one of those. Like that. I don't know. Another box right here. Okay. That's a semi-regular. Good, good? You don't have to draw those figures, but I'm just kind of trying to illustrate this. Okay? Good? All right, uniform and not uniform is a little bit tricky. Okay? Uniform looks at the intersections. Like, you see where A is here and B is here? Where A and B are. A is talking about the different intersections that we have. Okay? A is this guy. How many lines are coming together to make this vertex? 1, 2, 3, 4. We have 4 intersections there, or like 4 places where he's coming together. Okay? B, how many places or how many intersections are coming together to make that B? What? 1, 2, 3. So he is not uniform, because different intersections are going to look different. The intersections have to all match and be identical in order for it to be uniform. So I'm going to say the intersections are identical. Okay, not uniform. The intersections are not identical. Is that hard to see? You can pick any places along here where 2 shapes are coming together. And if one of them is not matching the other one, then it's not uniform.
What do you mean by like the intersection being identical?
Like where 2 shapes come together. So I can pick any joint, right? Like let's say I pick this joint right here. That's where 3 lines are coming together, right? If I pick this joint, 1, 2, 3, 4 are coming together. Those don't match. Okay? Yeah. Versus like, let's say if I do all squares that are intersecting. Square, 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 square.
No.
Okay? If I pick this intersection, I have 1, 2, 3, 4. And this intersection, 1, 2, 3, 4. And this intersection, 1, 2, 3, 4. And if you would repeat over and over again, every intersection or every place where the shapes are coming together look identical. Does that make sense?
So like if you had like a bunch of hexagons like in like a honeycomb kind of thing, that would be?
Let's look at like this guy right here. Okay, so actually let's go ahead and fill out this. We'll come back to your question here in a second, Megan. So if I'm looking at this shape right here, they want us to fill this in. Is he going to be uniform or not uniform? Not uniform, because he has 4 intersections here versus only 3 here. So it says the tessellation is not uniform because vertex A, there are 4 places, and vertex B, there are 3 angles. Okay? And then we need to decide, is the tessellation regular, not regular, or semi-regular? Is he regular, not regular, or semi-regular?
Not regular.
He is one shape. They're all rectangles, right?
Yeah.
So that means he's not semi-regular. That we can cross off. Is he regular or not regular?
No, he's not regular because not all the sides are the same.
He's a rectangle. A rectangle is not a regular object. All the sides would have to be exactly the same in order for that to work. So he is not regular because a rectangle tile is used to create a pattern and a rectangle is not a regular polygon. Okay, does that make sense? Let's go down to this one. All right, so we need to decide, is he uniform or not uniform? So let's pick an intersection right here. That guy, we have 3 of them coming together. 1, 2, 3. Let's pick this guy. He is 1, 2, 3. Let's pick this guy. 1, 2, 3. This guy, 1, 2, 3. Regular, not regular. Or no, excuse me. Uniform, not uniform. Uniform. Okay, regular, not regular, or semi-regular? Not regular. Because rectangles are not regular figures. Do we see how this works?
Yeah.
Not too confusing? You get it? Okay.
It just
All right.
confused me a bit.
Good, good. Yeah, yeah. And you have to see a couple of examples before you're like, okay, that makes sense, right? Good. All right, we're going to skip example 4. Do 1 through 7 for homework.
That's it.
I think we did number 4 together just to get you a start on number 4. Do you want to see that one?
Can we
Yeah? Pentagons and squares. We want to see if the pentagons and squares will tessellate. So I'm going to try to draw. I'm going to attempt to draw some pentagons and some squares. Pentagons have 5 sides. A pentagon and a square. And a pentagon. And I don't know. We want to see if he works.
Bro, there was a trial here. And everybody said turn it in.
Yeah.
I'm like, I'll go turn it in.
Who said turn it in? No, you said to turn it in. I
Okay.
gave it to you.
All right, let's look at this intersection right here and see if he comes together. Let's see if he works right there. Okay? So I drew some, so I have a pentagon, a pentagon, and then a square. And then he like flowers around. Let's see if this ends up working. Okay? Or maybe this should be a square. I don't know. Should this be a square over here? I don't know.
Yes.
You think he is?
Yeah.
I don't know. Let's see. Let's find out. Okay?
Is it a pentagon?
All right, so a square is going to have a 90-degree angle. So he's a 90, he's a 90, right? For a pentagon, pentagon has 5 sides. That means he has how many triangles? 3 triangles. 3 times 180 is how much? 540. Okay, then we divide by 5, so that is
108.
108.
Yeah.
Okay, so this is 108 degrees, and this is 108 degrees. Okay, and let's say we have a 90 and a 90. Can we get those to add up to be 360? What?
396.
396? That doesn't work?
Plus 108 plus 108. That's 396.
So try if this is 90 and this is 90 and this is 108 and this is 108. Does that add up to be 360?
I'm too hungry for this.
Well, if that's what I took, 90 plus 90 plus 108 plus 108, that's 3.
And that doesn't work? Okay, try and see it. Oh, and that's 3 what? 96? So that's already too much. What if we have a 108 and 3 90s? A 108 and 3 90s, would that work?
378.
378. Is there any way we're going to get to be 360 if we combine any combinations of 90s and 180s? Or, and not 180s, 108s. I think the 8 in there throws it off. Because he ends in an 8, and that's not going to work. So I don't think this is going to work.
So no.
There's no combinations of 108s and 90s are going to end up giving you 360. So pentagons and squares are not going to tessellate. Does that make sense?
Yeah.
If I look at all those together, there's no combination of them that I could do. Okay. Good?
This is the homework.
This is the homework. That was number 4.
Can you
Okay.
get our papers back?
All right. So you just do 5, 6, 7. See what you can come up with. Okay?
Are they?
All right. Goodbye, Chloe.